Okay, this is Mr. Great Tech Review here in Mr. Great Tech Review Studio, bringing you technology to your doorstep. And here we come again with tutorial number 20 on for loop command. For loop command. On tutorial number 18, we did a dimmable LED. And on that tutorial, if you have not watched that tutorial, go back and watch the tutorial and watch all the previous tutorials so that you'll be able to understand tutorial number 20. It's a collection of tutorials from tutorial number 1, understanding how Arduino works, to tutorial number 20. And here again, we are on tutorial number 20 on for loop command. It's a very simple for loop command. It's a very simple command, and we are going to use a counting variable, which is J or I, and I choose to use J because I like using J. Situation whereby you have I and you have 1, you find it difficult to debug, so I choose to use J because it's a difference between, it's a clear difference between J and 1. You can be able to debug your program if you have a mistake where you have a combination of J and 1 together. You can be able to differentiate which one is which, so I use J as my word, as my counting variable. So let's log down to the program and see how we can use J as my counter in my for loop command. So okay, I have my Arduino. Remember, you go to bare minimum, go to examples and you go to bare minimums and you launch your program. You start coding. Now I have my first program. Like I said, I'm not gonna be typing program here in our tutorial to save time, but I'm gonna explain my programs, my coding, so that we'll be very fast about it instead of spending too much time on writing and coding here. I've already written the programs, then I explain and you go along with me. So you open your program and let's go. So I have my first for loop command, then I have my third one where I use, okay, the first one I didn't make use of the J, the counting, the J variable. So it's just a simple delay program where I blink the LED, the white LED, how many times? That should be 6 times, and the red LED is 3 times. So let's, just a simple delay program. You must have seen in my Morse code program where I did the Morse code, the dit da da dit, just the same program. Just go back to the same program. You just do copy and paste. If you can't be very fast about it, you just go to the same program, just do copy and paste. So you have, we'll declare our variables. You have the int, the red pin. I choose pin number 2 on my red pin. Pin number 2 is my red pin, and pin number 12 is my white pin because I choose to use pin number 12. Then my delay time is 1000 milliseconds. And my pin mode, you have pin mode, red pin is output, as you know, it's output pin, and the pin mode, white pin is output. And I open my serial monitor in case I want to print out something on my serial monitor. So it's as simple as that, as simple as ABCD. And let's go down to the program again. Then I have my digital write, red pin high in my void loops, where you loop your program, want it to repeat itself. It's a loop station. If you play music, you loop, you want the music to repeat the number of times you want it to repeat. That is what the void loop is all about. This is where you loop your program. This is where your program is being executed, the number of times you want it to be executed. And invoice setup is where you set up your program. This is where you give a set of instruction on what pin that you are using. Pin mode, you say red pin output, that is red pin is always, will remain always is the output pin, can never be input. And pin mode, white pin, which is what is also output. And your serial monitor, you put your baud rate 9600. I choose to use 9600 because I like using 9600. There are other baud rates that you can use, which is very good also. Okay, so on void loop, I will not explain much on void loop. It's just like piston and rings scenario, just like I use the mechanical engine to explain. Once the piston and rings start moving, up and down movement, and the vehicle start moving, that is just it. Just as a very simple explanation of how void loop works. The up and down movement of the piston and rings keep the vehicle moving. And once it jumps 1 and 2 and stop, the vehicle stops. So the same thing here. So as far as you keep on looping, your program keep on what? Void loop. It's a looping station. Your program keep on executing, endless execution until you stop the Arduino. Okay, that is it. If you reset, if start again, start afresh, So that is it for void loop. Okay, so digital write red pin high, put a delay time. I use delay time as my variable here. You have your delay time as what? Your delay time as 1000 what milliseconds. I didn't understand delay understand timing on milliseconds, not on seconds. Okay, so that is it. And you have digital write red pin low, and you have delay time of what? 1 second, which is 1000 milliseconds. That is it. Then you duplicate this program. I want to count red pin 3 times and the white pin 6 times. So I just do copy and paste. You can just see it is just copy and paste. I copy and paste it 3 times. 1, 2, 3. Then I go to digital write, white pin high, delay time, digital write, white pin low, delay time. I do the same thing, copy and paste. I pasted it 6 times. And we execute this program and we see how it goes. Remember, in my hardware configuration, I will show you how I did my hardware. Let me show you my hardware. Okay, so this is my hardware. If you do your Morse code very well, coming up. Okay, so this is my hardware. Then I have my components in my hardware. I have my my breadboard, and I have my LED. I have my linear resistor, my linear resistor, not variable resistor this time around. We use fixed resistor, sorry. And I have my jumpers, my black jumpers for my for the ground, and I have my yellow jumpers for the first LED and the second LED. And what again do I have here? And that is it. That is all. So you have your red pin. Let's start with red pin because the program starts with red pin. You have your red LED. I'll come very close, bring a very close shot of this so that you will see it very well. I will still come very close. 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 Okay, that is the end of the. Okay, so that is it. So now you have the red LED which is blinking. We'll make it not to blink. Let me remove it so that it will not be flashing on the camera. Okay, very good. So I have the red LED here with me, and I have the white LED because I choose to use white LED. You can also try different colors of LED, but I choose to use this one. Okay, so I have my first resistor connected in series with the first leg of the positive leg of the red LED, and goes to this place and comes to this jumper, this yellow jumper, and then goes to pin 2 of my Arduino. Goes to pin 2 of Arduino. Goes to pin 2 of the Arduino. You can see pin 2. This is pin 2. This pin is pin 2 of the Arduino. You can see it's pin 2. Pin number 2. Okay, this is pin number 2 of my Arduino. It goes down here to what? It goes down here to this place. Okay, let me bring you a shot ahead. Very good one. So look at it here. Okay, so now then I have my white LED. I have the positive leg of the LED, which is the longer leg, goes to this resistor. From this resistor comes up to this jumper, and look at it here. It moves and goes to what? To the pin 12 of my of my Arduino Uno board, because I choose to use pin 12. You can also make use of any other pin from 2 to 13. From 2 to 13. Okay, so that is the end of it. And you have the white pin. This is my I have the white jumper, goes to the ground, and the ground, this is my ground of my breadboard. Okay, this is the ground of the breadboard. So I have my white pin goes to the ground, the first ground. Then I have the loop where I loop my the other leg of my LED. I loop them to the to the ground of the breadboard. So I have the first one, I looped it. I have the second one, I looped it. It's a very simple configuration. If you watch our Morse code, you understand. And very simple. Then you have your USB connected here. You have your USB. Then you connect to the system to program, to code, to write your program. And it's as simple as ABCD. So I will go back a little bit so that, okay, very good like this. Okay, so that is it on on the hardware connection. So it's very simple. So now we can now plug it in, then we can now flash the program. It's already inside, but for tutorial sake, let me just plug it in my system. Okay, I have to bring up my okay. So okay, okay. So now we have to. Okay, I have to remove myself. Let me remove myself so that I can use. Okay, very good. Use this camera to demonstrate. Okay, now so on those, after writing your program, you can now go to upload. Here you upload your program, and let's say it's happy. You have the happy green bar showing that my programs are okay, my coding is okay. Okay, now very good. Now you can see that the red LED blinks 3 times and goes off, and waits for the white LED to blink 6 times. Okay, the lighting is much. You can off the lights so that we can be able to see this. Okay, so now we see the white LED blink 6 times. So let's reset. Like I told you, see your reset button in your Arduino here. This small button is reset button. So let's reset and start again. Okay, start with what? The red LED 1, 2, and 3. It goes to what? To white 1, 2, 3, 4, 5, and 6. And the program returns back to what? To the red LED. Now we are going to introduce a variable, a counting variable called the J, so that we can come up with our what? Our for loop command. Now for loop command, what is for loop command? For loop command is a way of writing this program in a very simple sentence, in a very simple simple line of program. So we are just going to make only 2 line of program. We use only the first one in this place, and that is the first in the void loop. Let's go to the void loop and see. We use the first set of program, the first set of instruction, which is the digital write red pin high delay time, digital write red pin low delay time. We use this one, and we use that of the white pin, and we use go down, we pick one of the white pin, then we introduce our for loop command, and we still achieve the same what? The same result. Okay, so let's go. I've written all of them, they are here with me. Okay, so now I have my for loop program. This is Mr. Great for loop command 2. Okay, this is where I declared my words, my variables. Okay, let me just make it very simple. Okay, you have your int. This is the first. Okay, sorry, you're not seeing. Okay, so this is the first where you have your first okay, okay, so this is where you have your first program. Red pin is equals to 2, white pin is equals to 12, blah 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 blah. The same thing. Okay, int delay time 1000. Okay, now this is the difference between the for loop command and the other command you have written, which is normal delay command. You use normal delay command, and you write your program. So we are going to introduce something that is different from this program. You look at this program, you look at this program. This is where it ends. It ends on delay time, and this one continues after delay time. You have red blink equals to what? 3. And the white blink is equals to what? 6. Remember, red blink, I said we are going to blink the red LED 3 times, and that is it. So you put semicolon, and white blink 6, white blink 6 is equals to 6. So we are going to blink the white LED 6 times. You put semicolon. Then this is where the game has changed. And int, there's another new guy in this place, and this is what? The J. The J counter. This is a counting variable. This J is a counter. It's a counter. So we introduce J, and then J int. We are not going to declare J because J is just a counter. It's a counter. It's a counting variable. So it can count from 1 to any to endless. So we are not going to declare it because it's going to count. So we are going to declare wherever we want it to start counting inside the program. So j int j semicolon stop. You stop there. Okay, so that is it. Now pin mode, red pin output, white pin output, and the serial.begin. I activate my serial monitor in case I wanted to print out something. I'll write print in line, j, this and that, blah 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 blah, stuff like that. Okay, so that is it. And now I go where I will introduce my first set of instruction on the void loop, where I have the for command. That is the for command. Now the for loop command. Okay, so before the for loop command, I'm going to show you something in this command. This is the command you have to okay, I'm coming so that I'll put myself so that okay. Now in this for loop command, you have the for, F-O-R, that is the for F-O-R, for. Okay, now for loop command, now you have j is equals to 1. Very simple. I'll explain this set of instruction. J is equals to 1. Remind you, in Arduino understands linear equation. It's very simple. Arduino works with equations. So when you say j is equals to 1, that means you want j as a counter to start from what? To start counting from 1. J is equals to 1. So when you say j is equals to j plus 1, that means you added a 1 in the counting. So it will count. After executing the red blink, it will go back again and add 1 to that red blink, and add 1 to j, and it becomes 2. It will execute again. It will also be continuously. It's a looping program. It will continue. So it's a counting program. So now let's go and write this program with j. J is equals to what? Is equals to 1. For loop command. You put 4 in bracket. It says j is equals to what? Is equals to 1. Okay, semicolon. J is what? Now j is less than or equal to red blink, and our red blink is what? You are blinking red LED 3 times. Red blink, j is equals to, okay, j is less than or greater than what? Red blink, semicolon. Now j is equals to j plus 1. Now I will explain this code. Now you put glory, you open glory and you close glory for the for loop command. Remember, you have the first open glory and you have the last one. This open glory is this one is for the void loop, and it ends here down to the okay, it now ends here. This is where it ends, down here at the end of the program. That is where it ends. Arduino automatically fixes that one for you. When you start coding, it just fixes it for you. It's there for you. But in the for loop command, you have to introduce the open glory binding the what? The looping command, the for loop command. So this open glory is the one binding the what? The red pin, this one. So when you finish, you put it at the end of it, you put it here, you put this one. So without it, your for loop command is not going to be executed. So that is it. So these are the tricks you are going to learn. Sorry, look at it here. Without it, it's not going to execute. So these are the tricks you are going to learn, and these are the difference between other set of instruction and this set of instruction. In the normal program, you don't put it. Now in for loop command, you use this. So that is the difference between, and also, and the for loop, the j as a counter, where you have your set of instruction inside, is inside a bracket. So you open a bracket, you close a bracket, and you put your set of for loop command instruction inside of it, and this open and close glory binds all of them together. This is where it binds all of them together. So that is it. So you must learn the programming language. It's not my language, it's a programming language, just like you learn A, B, C, D, E, F. Whoever tells you that A is A, you believe the person, and you never argue that A is A. You have not seen A before, and somebody writes something and say that is A, and you believe. So that is the way you also believe this. So this is a programming language, it's a language. So you believe it and you write it, it works for you. Very simple. Okay, so that is it. And I've said it before that in this programming, in this Arduino coding C++ language, that expect to see anything expect to see anything. Whatever that tells you that this is how it works, you believe it. If you don't want to believe it, you cram it. And whenever you apply it, find out that it works for you. But you must have a simple understanding of how this thing works. That there's a set of instructions. I did not understand set of mathematical instructions, most especially linear equations. It's very simple. It works with equations, and by the time in our previous tutorial, I saw where we did some calculations on the slope of the line and the equation of the line. And before you get the equation of the line, you must find the slope of the line, and from the slope of the line, because the equation of the line contains slope, so you get the slope of the line, then you add it to the equation of the line, and you'll be able to combine the digital right and what the analog read and digital write. So in analog read, like I told you, the analog read, you have a set of scale value from 0 to what 1023, and in digital write you have a scale value of what 0 to what to 255, and for you to combine both of them together, you have a different scales. So you need an equation of the line that will bring 256 and 1023 together, so that Arduino will understand and gives you result. If not, it will execute. If you are using 1023 scale value, it will stop at 1023, and when the output stops at what the output stops at what 255. So when you get to 255, it stops there, and it's not going to execute further because you didn't bind them together. So you use that set of linear equation, the slope of the line, and the equation of the line, to bind the two of them together, to have a the two scales to work together, and for you to achieve your result. So very simple. So in this place now, it's a different thing altogether. It's a set of mathematical equation inside this place. Very simple. J is equals to 1, and the counting variable will start counting from 1, and J is equals to J plus 1. It will add 1 from 1, it becomes 2, and at the end of the day, it will also be adding 1. If you say J is equals to J plus 2, it will start adding 2. So that is how this thing works. A lot of mathematical guys will like to understand how we arrive at J being 1 and how we it doesn't work that way. So that is it. Okay, so it's very simple. Now J is what is less than or equals to what red blink, and J is equals to J plus 1. So let's do it in our paper so that I will be able to clarify this, because it's somehow difficult for some guys to assimilate this. And very simple. Okay, and you have your first one. You say that what? Okay, J is equals to 1. Okay, and J is less than or equals to red blink, and red blink is what 3. Okay, let's say red blink. Okay, red blink. Okay, blink. Very good. J is equals to or less than that red blink. Okay, then you said again J is equals to what? J plus 1. Very good. And J plus 1, J is what? J plus 1 is 2. Okay, let's go. And red blink is what? So let's write this and say, okay, so J is equals to 1. J is less than or equals to what? Red blink, which is what? 3 times. See? Which is 3. Okay. Okay. And J is equals to, okay, 1 plus what? 1 plus 1, which is equals to 2. Very good. So let's go back to the program and let's see how it works. Okay, so that is it. Okay, so red blink is what? 3 times. We are trying to write the first set of instruction, the first set of program, the first set of code. Red blink is 3. Okay, so let's go back to the paper again, just like I said. So J is what? Is less than or equals to what? 3. J is less than or equals to 3. Okay, so very good. Okay, so let's go. So since J is equals to what? And let me bring my camera 1. Okay, and Okay, I think it's okay now. So that we can see both of them together. Okay, so now, and the red blink is equals to what? 3, and the j is greater than, or j is less than or equals to 3, which is red blink. Okay, now let's execute this program. Let's execute the program. It's very simple. Very simple. Whenever you start doing some mathematics, some people start becoming afraid. It's a very simple mathematics. It's not divide the x. It's not quadratic equation. These are simple equation, straightforward equations. Very simple. Okay, so and in the program you said j. Okay, let's start again. And j is equals to 1. J is equals to 1. Okay, comma, and semicolon. Then j is less than or equals to red blink. J is less than or equals to, so j is less than or equals to 3. That is, then j is equals to what? J plus 1, and j plus 1 is equals to what? Is equals to 2. Okay, so now let's start and start writing it again. Okay, j is equals to 1. So j is equals to what? Is equals to or less than, j is equals to 1. Let's start with j is equals to 1, and j is less than or equals to 3. So, and j is what? Is j plus 1. So 1 plus 1 is equals to 2. So that is it. So let's say j is equals to 1. The set of instruction, let's start with it. So 1 is equals to, 1 is less than or greater than what? 3. And let's say, is it true? Yeah, there's some element in this program that is true. 1 is less than 3. It's okay. Or equals to 3. It's not equals to 3, but 1 is less than 3. So Arduino will see it and say, okay, yeah, 1 is less than 3. Therefore, I will give the pin high. Okay, I will say high. Okay, very good. Knowing that j is what? It's equals to 1. Okay, your first set of instruction. Okay, very good. This one, it goes again. He said j is what? J plus 1. Okay, so and j is 1. It's okay, 1 plus 1. J is equals to j plus 1, 2. Okay, it's 2. It's less than or equals to 3. Is it true? Yeah, 2 is less than 3. It is not equal to 3. Well, okay, so it will take 2 is less than 3 or equals to 3. Okay, it's true. There's element of truth inside of it. So you say high. Write high again. Okay, very good. There's another one. It goes again. Start again. Count again. And said again, j, that is 2 for you. It adds 1 again. Then, and 2 is equals to, then it counts again, j is equals to j plus 1. And j now is 2. So now 2 plus 1 is what? 3. 3. And 3 is what? Less than or equals to 3. Oh, 3 is not less than 3. 3 is equals to 3. Very good. High. If you write high again, it gives your pin output high. Okay, very good. Now it comes again. Let's go again. 3 plus 1, because j is equals to j plus 1. So, and j is now 3. So 3 plus 1. 3 plus 1 is 4. Okay, 4. It's less than or equals to 3. No. Okay, there is false. So since it's false, it becomes low. So the pin stops there. The program on the red blink stops. The program on the red pin stops. Now it will now jump to what? To the white pin. It will now jump to this place. So here now is false, low. So it's going to count what? So it's counting what? 1, 2, 3. Only 3 times. 1, 2, 3. And here, low. So you're now going to jump to this place, to another set of what? Instructions, another set of program, and the same thing follows suit. Follows the same sequence in this place. And this place, he says, okay, it goes to, okay. Yeah. So now white blink, he said white blink is what? Is 6. So you repeat the same program again on the white blink. Okay, this is 6. I will use my green to write the 6 on. So j is equals to what? Is equals to 1, and J is equals to what? Red blink. This is white blink. White blink. Blink. And J is equals to what? J plus 1. Very simple. Okay. J is equals to 1. And J is less than or equals to what? 6. Because you said white blink is what? 6. The white blink is 6. So now look at it, 6 here. This is 6. So now J is equals to or less than 6 because you are trying to blink the what? The white pin 6 times. So inside your variables, you have also written that white blink should be is what? Is 6. You have given it that set of instruction, and the white blink is on what? On pin 12. Pin 12. That is the white pin here. This is the white pin here. Pin 12. This is white pin, and this is white blink. This is the instruction. This is instruction to blink what? To blink this guy what? 6 times. So this is it. And so J now, we're introducing the for loop on this command, on this set of on this line of instruction on the white pin, and you said, well, what? That J is equals to J is less than or equals to what? White blink. So that is it. So now let's go back again and see, and J is equals to what? J plus 1. And J plus 1 is equals to what? 1 plus 1 is equals to 2. Okay, and J is equals to what? J plus 1. Okay, now let's do it and see. Okay, now J is equals to 1. So 1 is what? Greater than 1 is less than or equals to 6. 1 is less than 6. So I'm going to get what? I'm going to get high. I'm going to get high. So it's going to come up. Okay, now let's go again. And J plus 1 is what? 1 plus 1 it becomes what? 2. And 2 is what? 2 is less than or equals to 6. Okay, is it true? Yeah, it's 2. There's an element of truth inside of it, because 2 is what? Is less than what? Is less than 6. I will tell you the reason why you put equals to, because some guys will say, why am I putting equals to? I could have removed. I will show you. When we remove equals to, you give that a set of another mathematical instruction. It will get to some point, it will not count to the end again. It will count only 2 times. When you remove the equals to, it will count only 2 times. When we remove it, we'll do the mathematics. You see why we should put equals to. We'll get to that one. Okay, now, okay, the same principle. You said, okay, J plus 1, that is 2 plus 1, what is 3? And 3 is less than or equals to 6. Yeah, high. It's less than 6. Then J plus 1, this set of instruction again, comes to this set of instruction again. J plus 1, 3 plus 1, 4. 4 is less than or equals to 6. Yeah, high. Good. Okay, so we are moving. Then J plus 1, 4 plus 1, 5. 5 is equals to 5 is less than or greater than 5 is less than or equals to 6. Yeah, 5 is less than 6. Okay, you have high. Okay, so you have how many high now? You have 5 high. 1, 2, 3, 4, 5. So 5 times now. It's still reading by your delay of what? Of 1 millisecond. So that is it. Now 5 plus 1 is what? 6. Okay, 6 is what? Is less than or equals to, okay, 6. Okay, no, 6 is equals to 6. Okay, it's high. It's high. Okay, so now I have how many high now? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. Okay, I have 6. Now J is equals to what? J plus 1. Okay, J plus 1. 6 plus 1 is what? 7. And 7 is what? This is 7 is less than or equals to 6, which is no. Okay, it's low, so it's false. So false, so it's low. So it will stop here, and we'll start with the first one and go back to what? And go back to this program and start with what? The red blink. That is it. It will come and start with the what? The red blink again. So it's just like I told you in the void loop. It's when the program ends, it will start from the first one. So the first set of instruction here. So now it ended here on 6. 7 is less than. 7 is less than or equals to 6. Lie. Foul. So it will stop here. It will go back again and start with what? And start with this one. And start with what? the red blink, and this is the end of the story. So this is the for loop command, and this is how you can use for loop command to shorten your program. Now, what is the advantage between this and the former program we write before? So let me put both of them together. But it's very simple. If you just go back and you see that this is just one, and this is just the program here. So very simple. Instead of you repeating this guy 6 times, instead of you repeating this delay program 6 times, you just have to do it once, and you introduce a for loop command here, counting a J command here, and you solve your problem. And you just put a very simple variable here, which is the white blink and the red blink. With this, you are done. Okay, in a case whereby I want to repeat, I make J, I want to make my white pin to count 12 times. So I will come here and change it to 12. So you see why this one is very easy and very simple. In case you want to add more values or change or add more flavor to your program, you cannot just come here and start adding copy and paste, copy and paste, copy and paste, copy and paste. You have a lot of set of instruction. Your program will be cumbersome, very difficult to debug when you have issue. So these ones are very easy to debug when you have issues. You find out that you can debug this program very easily because you just have simple set of instruction in front of your IDE. So you find it that is very easy and very simple to debug. So that is it. So that is the difference between both of them. Okay, so now let's execute this. Let's upload this program and see. Now we are finished and we understand this. Let's do it and see. Okay, boom. Okay, so that is it. Now you can see. Okay, 3 times. Okay, the white pin. 1, 2, 3, 4, 5, 6. Okay, very good. So now you can now see it starts again. So now, okay, let's make some changes. Let's reduce the delay time so that you can see the importance of using your variables, and let's reduce it to what, to 500, and so that it can be a little bit fast. Okay. Now let's go again. Let's add some changes and let's see. Okay, half of a second. Okay, let's go. 1, okay, 2, 3, okay, now, okay, 6 times. Okay, now, okay, let's reverse the case. Let's make this one 6, the red blink 6, and the, okay, let's just make it 4, red blink 4, and okay, now let's just make white pin and the white blink 3. Let's make it 3 and see. So both of them 3 times. Let's upload and see. Okay, you see, it's very easy to correct. If you make mistakes or you want to correct it, okay, that's just it. Okay, 3 times. Okay, go again. Okay, very simple. So that is it. That is the end of the drill. And I believe with this for loop command, you can also do some amazing projects with your Arduino Uno. And okay, that is it. Okay, very good. Okay, now there's no other changes here, nothing. You can make changes. Okay, let's go back and remove equal to in this program, and let's see, because this is where some guys are getting it confused. Why should I put equal to? I could have said J is less than red blink. Okay, let's go, let's do it and see. And okay, let's remove it and see. And okay, let's upload. Okay, and let me adjust the program to the way it is before red blink. Okay, this one is 6 times. Okay, and 6. Okay, so let's go. So what I did now, I removed equal to, Okay, just watch and see. Okay, 6 times, and breadbean has to go 2 times. 1, 2. Okay, let's go again. It's only 2 times. Okay, what is the meaning of this? I will use only this to explain this. It's very simple. Now you said J. Let me. Okay, you have seen what happens here. Now let me remove the Arduino. So let's solve it. Let's solve this program and see. Now you have J. Okay, let me use my, because I use it's red blink, so I use my red. Okay, you said J is equals to 1, and J is equals to what? Red blink, and J is equals to J plus 1. Okay, and you said J, let me just start from here. J is what? Is less than 3. Okay, let's solve the problem. J is less than 3, and J is J plus 1, and J is 1, so 1 is less than 3. Abi? Okay, which is what? High. Okay, I have high. 1 is less than 3. I have high. 1 is less than 3. Very good. 1 is less than 3. You have high. And J plus 1. 1 plus what? 1 plus 1 is what? J plus 1. J is what's the J plus 1. So 1 plus 1 is what? 2. And 2 is what? Is less than 3. Everybody believes that 2 is real. Okay, you say high. Okay, very good. 2 is what? Is less than 3. High. Okay, now let's do again. Okay, so and J is what? J plus 1. So 2 plus 1, 3. And 3 is less than what? 3. Okay. 3 is less than 3. Oh, low. Cannot work. 3 is less than 3. No way. 3 is not less than 3. 3 is equals to 3. So you see why we put this one. So this is it. So I think that's, I've solved that that problem, and I believe I've done justice to that. And this is where this is when we start putting this equal to, equals to, equal to, equal to, equal to, equal to, equal to. This is where it enters. This is how it enters this problem. So it doesn't mean anything if it is here. The Arduino executes this one, and when this one becomes when this one is out, it executes this coming to this place. This one is no. It sees this one and it executes this one, and the next line of this thing is okay. 3 plus 1, 4. 4 is equals to 4 is less than or equals to 3. That is what? Okay, this one now becomes high. Okay, because I've corrected it. Okay, now 4 is what? Is less than or equals to what? Or both of them are 4, so it now becomes low. Okay, now you have 1, 2, 3. Now 3 times you have already counted what? 3 times. So you see now the red blank becomes what? 3. So that is how we got to use this guy here. So it's very simple as A, B, C, D. Okay, thank you. And I've done justice to all of that. I've done justice to all of that. So I don't think I have any problem again. Okay, so that is it. Okay, so this is Mr. Great Tech Review here in Mr. Great Tech Review Studio, bringing you technological updates on our Arduino Uno tutorial number 20. We have learned the for loop command. So like and share this program if this program makes sense to you. You like and share so that others will benefit. I'm your one and only Mr. Great here in Mr. Great Tech Review Studio. Bye bye and God bless you. See you on our next tutorial, on tutorial number 21. And tutorial number 21, we will continue on for loop command, the interfacing for loop command with our serial monitor. Now we are going to print numbers in tutorial number 21. You see the same for loop, but we are going to print number using our. Now you see whatever we did it on what the software aspect of it, and the program you saw the hardware aspect of it, which is this one, the LED counting for you. Now we are going to use the serial monitor to count the number. You see it's counting, it beep what 3 times, and can use the serial monitor to count it. Then the other one 6 times, you still use the serial monitor to count it, so that you see that everything we are doing here is whatever and however you are going to interpret it, it still gives you the same result. So see you next time on tutorial number 21 with serial monitor and for loop. God bless you. Bye bye for now. Like and share.